Okay, number 18. So we are solving with the quadratic formula. So we need to move the -9 over to the left. We add 9 to both sides. It becomes +9 on the left from the right. And now we need to plug this into quadratic formula. Okay, so now we simplify. So we need to simplify what's underneath the radical sign. So 3 squared minus 4 times 9 times 9 is 9 minus 324. So that is 315. And that is negative 315. Okay, so now we need to simplify 315. So we have -1. Let's see if we have any factors of 315 that are perfect squares. So we see that 315 is 9 times 35. 9 is a perfect square. So the square root of 9 is 3. Square root of -1 is I. Square root of 35. So we have -3 plus or minus 3i square root 35 over 18. Now, hopefully you are starting to recognize that if ever we have a common factor on those 3 outside parts, then we're going to need to reduce. Okay, we could split it into 2 fractions. If you want to see that, let me know. We can talk about that. Or just divide all 3 parts by 3. So that gives us n is equal to 1 plus or minus I square root 35 over 6. Or 1 plus I square root 35 over 6. 1 minus I square root 35 over 6, split into the 2 answers. Number 19. We see from the highest exponent that this is a degree 3 polynomials. We're expecting 3 zeros. Okay, we could either have 0 imaginary or 2 imaginary. Okay, you have to have the imaginary because there's no i's in our polynomial. The imaginary ones have to be in pairs. So if there's 0 imaginary, there's 3 real. If there's 2 imaginary, there's 1 real. So next, possible rational zeros. So we do p's over q's. So the p's are the factors of the linear term. So we have plus or minus 1, plus or minus 2. The q's are the factors of the leading coefficient, plus or minus 1, plus or minus 2, and plus or minus 4. So now our list of possible zeros. We make fractions. 1 divided by 1 is 1. So I'm going to list these. 1 and -1. 1 divided by 2, we have 1/2, -1/2. 1 divided by 4, 1/4, -1/4. 2 divided by 1, we have 2 and -2. 2 divided by 2 is 1, but we've already listed that. 2 divided by 4 is 1/2, and we've already listed that. Okay, so those are the possible rational zeros. We need to find which ones actually work for the polynomial. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. We could plug them in. Okay, plug in the 0 and see if I plug it in, which one will give me a value of, if f of that number comes out to be 0, that means it goes in. The first thing I'm going to do is I'm going to try to factor, because I'd personally rather factor than plug in all these numbers. One thing some people do is open up a spreadsheet so they could plug in a lot of numbers at once. But let's see if we can factor 4x cubed, x squared, negative 8x, and negative 2. Let's see. The top row, x squared, would factor out. X squared times 4x is 4x cubed. X squared times 1 is x squared. 4x times negative 2 is negative 8x. And negative 2 times 1 is negative 2. So if we're finding the zeros, let's put a 0 here. We can factor this into x squared minus 2, 4x plus 1. Okay, so hopefully you can see, if you could factor it, you could actually skip a lot of work. I like to try and see if I can factor it. Okay, so now we're going to split and solve. X squared minus 2 equals 0. Add 2 to both sides and take the square root. Can you see that this is two factors right now? Yeah, degree of 2. So we have plus or minus rad 2. Okay, and now 4x plus 1 equals 0. Subtract 1 from both sides, divide by 4. So we have rad 2, negative rad 2, and negative 1/4. Okay, so your question is, if you are coming in to take this test, is this really going to be on the test? Now, your test has, yeah, okay, so if you're taking the online version, yes, expect to see this. If you're taking the in-person version, so this does show up as one of the extra credit problems. Okay, so if you are able to master this, I know it's a lot of steps. And once you get to this part, there's different options. Take all the zeros and plug them in. Take all the zeros and do synthetic division, long division, or try to factor. Okay, so there's a lot of steps. If you can master this, then it's worth an extra credit on the in-person. And it is possibly going to be on the online version as well. Now, I'll give you a hint. On the in-person version, there's going to be a little number right here. Let's say negative 1/4. I've given you a hint. I've told you one of the zeros. So you could do long division or synthetic division to start breaking it down. So we can talk about that if you have questions. Number 20. So from the highest degree, the highest exponent, we say we have a degree 4. We have 4 zeros. The imaginary could be 0, 2, or 4. If the imaginary is 0, there's 4 real. If the imaginary is 2, there's 2 real. And if the imaginary is 4, there is 0 real. Now, there's something here. Now, this is degree 4. That's a lot of factors to find. But there's something we need to start with. Do you see that they all have a GCF of x? So we are going to factor out that x And already that has brought that from a degree 4 down to a degree 3. So we have already found one of the roots. Okay, now let's find the possible rational zeros. So that's the p's over q's. Okay, so the p's, we have the factors of 12, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Whew, that's a lot. Those aren't as fun. So anyway, and the Q's are the factors of the leading term plus or minus 1. So the possible rational zeros, we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, because I took them all, made fractions, divided by 1. So now we can plug all of those in to figure out which ones go in, divide evenly, and will give us, when I plug it in, I get a 0. That means it has a remainder 0. That means it's a root. Okay, so we could practice that. We could throw it into a box and factor. Let's say, for example, I give you one of the roots is -3. Okay, so on the exam, it's going to have like semicolon -3, meaning I have given you one of the roots. What would you do next? Okay, we took the x and we pulled it out. Now we know that x plus 3 is a factor. I could either do long division with x plus 3, or I can do synthetic. Yeah? So if I've given you that this is a root, then I'm going to do synthetic division. So we have, now notice we've broken it down. We've already pulled out the x. Okay, so -3 is the root. What do we do next? We do the coefficients. 1, 3, 4, 12. Step 1, bring it down below the line. Step 2, multiply and put it above the line. Step 3, add down. Step 4, multiply, add down, multiply, and add down. Okay, so what do we have so far? This was x cubed. So now it's come down a level to x squared plus 4. Okay, so we have this one. We have x. We have this one, change the sign. Okay, can we find the roots? So the roots, we have 0, -3. I need 4 of them, right? I have 2 more. Okay, so we need to solve this. X squared plus 4 equals 0. X squared, subtract 4 from both sides, move it to the other side, it changes sign. Take the square root. When I take the square root of both sides, I get plus or minus. Okay, how does the square root of -4 simplify? Square root of 4 is 2, right? Square root of -1 is I. There they are. Okay. So I have 0. Yeah. -3. Or here's the 0. Here's the -3. 2i and -2i. That, if you're in person, could you pull that off for a few extra credit points on the test? Yeah, you might as well go for it. The extra credit can help you and not hurt you. Okay. Number 21. Um, I think I meant to cut that one off. So we do quite a few of these word problems. So if you're watching me and you haven't done number 21, you can cross that one off. Number 22. Okay. So $3 flat fee, $2 per mile. One of those things happens once. One of those things happens again and again and again, and it's going to have the variable. So the part with the X, which one of those goes with the X? The one that repeats. So we're going to have 2x plus 3. 3 happens once, and 2 happens multiple times. So y-intercept of 3, slope of 2 over 1. Company B, $5 flat fee, so that's 5, and 1m equals 1. So that is your x. Okay, write a system of equations to represent the total cost for each company. B, determine how many miles you would need to travel for the cost to be the same. We want the cost to be the same. We want the two costs to be equal. So that means we're going to set them equal to each other. So y equals 2x plus 3, y equals x plus 5. We're going to use the substitution method. We have y equals y equals. We are going to set them equal to each other. Take 2x plus 3 and plug it in right there. So 2x plus 3 equals x plus 5. Isolate your variables, subtract 3, subtract x. X is equal to 2. Plug that in. Y is equal to 7. So at 2 miles, the companies are the same. Yeah. Can you see that this one starts lower? So if you're going less than 2 miles, choose company A. If you're going more than 2 miles, choose company B. There you go. Okay. Brenda and John are selling cookie dough. 4 packages of white chocolate chip and 14 packages of double chocolate give you a total of $280. So the white chocolate chip we're calling X, the double chocolate we are calling Y. Yeah, do you see the equation? 4x plus 14y. Is that an equation? Not yet. I need something on the other side of the equal sign. Is equal to 280. Okay. Now, 1 package of white chocolate chip. That's my X. 7 packages of double chocolate. That's my Y for 133. 1x plus 7y's are equal to 133. Now, take a look at this. Sometimes before I start, I look and I see I have huge numbers, 280, and I have a greatest common factor. of 2. So I'm going to go ahead and divide everything on both sides by 2. So I'm going to have 2x plus 7y equals 140. And x plus 7y equals 133. Okay, so I have 2 equations in standard form. We're going to use the elimination method. So we're going to add down. So this is how we use the elimination method. Pick a variable that would be easy to cancel. You can cancel your x's, you can cancel your y's. The coefficient needs to be same but opposite sign. So if I pick the x's, I'm going to have to multiply this by 2 to make it match, by -2 to make it same but opposite. So I'm going to pick my y's. Look how nicely they match. So I'm going to multiply everything on both sides by -1 with another color so I remember that I did both sides. 2x plus -x is x. 7y, take away 7y is 0. 140 minus 133 is 7. Now my simplest equation is that one. Plug in x equals 7. Subtract 7 from both sides. 7y equals 126. Divide by 7. Y is equal to 18. Now, this one looks the same, but there's a trick. Look at this. There's the trick right there. So we're getting better. This is the flat fee. This happened once. That's B. This is multiplied. This is M. Y equals 2x plus 3. Now look at this. $3 for every 2 miles. We could see that 5 is B. Now this is $3 per 2 miles. So a little bit more difficult. So I have y equals. I'm going to set them equal to each other. So y equals 2x plus 3. Y equals 3 halves x plus 5. I'm going to plug this in over here. 2x plus 3. I want to know, where is it equal to 3 halves x plus 5? Okay. I am going to eliminate the denominator, which is 2. So I'm going to multiply everything by 2. So this 2 cancels. So we have 4x plus 6 is equal to, what comes next? Do you see it? 3x plus 10. Subtract 6. 4x is equal to 3x plus 4. Subtract 3x. X is equal to 4. Plug it in. Y is equal to 11. So that one had a little bit of a trick. Okay, 25 on your own. 26, you can cross off. I don't think I meant to have that many. Sorry, no wonder there's 40 problems. Okay, number 27, find the rule for the table. So we see this goes up by 1 and up by 2. Okay, There's a typo here. This was meant to be 2, 4, 6, and 8. So 2, 4, 6, and 8. Okay, so y equals mx plus b. The slope is 1 over 2, right? Change in y's over change in x. The y-intercept is the y value where x equals 0. So we're going to back it up and we can see that that's a 5. You could plug a ordered pair into the equation and 5 would come out, but we could see from the table that b equals 5. So y equals 1/2 x plus 5. 28. Solve the equation. We see that the least common denominator is 5. We're going to multiply everything on the right and everything on the left by 5. So these cancel. So I have x plus 2 is equal to 10. Subtract 2, x equals 8. The problem showed up again. This one's on your own. It's good to have practice, but I don't think you need hints. Number 30. Which graph should have an imaginary root? Okay. So imaginary roots do not touch the x-axis. So the graph on the left has imaginary roots. These are the roots of the graph on the right. Simplify the complex numbers. I squared is -1. I cubed is -I. I to the 4th is 1. I to the 5th is I. I to the 6th is -1. Number 32. Write the slope intercept form of the equation. So slope is 4/3 and our point is -1, 1. So we're going to plug our point in. So we have -1 is equal to -4/3 plus b. I am going to multiply everything by 3. So those are going to cancel. -3 is equal to -4 plus 3b. Add 4. 3b equals 1. B equals 1/3. So y equals 4/3 x plus 1/3. 33. Let's review that base to the power, add 1 base to the superpower, multiply. Now, if we have x's on top and x's on the bottom, subtract. Okay, step 1. Let's clean up the top. Multiply the coefficients. So the x's, x to the 3rd, x to the 3rd add. Y to the 4th, y to the -2 add those. Now, superpowers, right? This is y to the first to the fourth, x squared to the fourth. So I'm going to put the x's first. X to the eighth, y to the fourth. Okay, subtract. Notice the x's, I have two more on the bottom. And notice the y's, I have two more on the bottom with the 4 on the top.